Good morning. We are looking at yet another way to solve quadratics, and this method is called completing the square. So we are going to be incorporating everything that we learned thus far with complex numbers and the square root method to do completing the square. So what we want to do with completing the square is make a perfect square trinomial. So the way we identify what that's going to be is if this is my trinomial, first I'm going to look at the coefficient on my middle term, and we call that b. So half of b is going to be what goes inside of my squared binomial. So x plus half of b. And then that half of b squared is the third term in our binomial. So these are the two things that we identify to determine what our perfect square trinomial is going to be. So let's practice that first. Here on this first example, my b is 10. This will focus. Half of 10 is 5. So this is going to be x plus 5 squared. And if I have 5 squared, that third term is going to be 25. Okay. Let's practice this again. On the second one, my b term is 11. Half of 11 is 11 over 2, and we're going to leave that as a fraction. 11 over 2 squared is 121 over 4. Okay. Then again, our b term here is negative 12, so half of that is negative 6. So this is going to be x minus 6 squared. And that third term is going to be negative 6 squared, which is positive 36. And last one, I have a fraction here. I need to find half of that. So I'm going to divide it by 2, which is the same thing as 2 over 1. And if I'm dividing fractions, we keep the first term, change the operation, and flip the second term. So this is going to be negative 6 over 10, which reduces to negative 3 over 5. So that's half of b. So x minus 3 over 5 squared is going to be from our perfect square, and when we square that term, we get 9 over 25. Okay. So let's put this into action. If I cannot factor this and it's not a perfect square, what I first want to do is get my constant to the other side. I want just the first two terms for what's going to be my perfect square trinomial. So I have x squared plus 8x. If I wanted to make this into a perfect square trinomial, my b term here is 8. Half of b is 4. So I want to turn this into x plus 4 squared. So if this is going to be this perfect square trinomial, that third term is going to be 4 squared, which is 16. So I turned this into a perfect square trinomial by adding 16. And if I add 16 on the left, I need to also add 16 on the right. So x plus 4 squared equals negative 14 plus 16 is 2. So we turned this into a perfect square and we factored it. Now this is our square root method. This is where that practice comes into play. I'm going to take the square root of both sides. So x plus 4 is positive or minus square root of 2. This cannot be reduced. And then the last step is to move that 4 to the other side. Okay. Let's practice this again. So on that time, our leading coefficient was 1. So what do we do if the leading coefficient is not 1? So first, I'm still going to move my constant to the to the right. That leaves me with 3x squared minus 6x equals negative 1. Now, I want to make this coefficient 1, so I'm going to factor out the coefficient on my first term, and then divide it on both sides, so I just have my trinomial on the right. So x squared minus 2x equals negative 1/3. Now, I want to turn this into a perfect square trinomial. So half of my middle term, negative 2, that's negative 1. So I want this to be x minus 1 squared. So if this is x minus 1 squared, that third term is going to be positive 1. And if I'm adding 1 on the left, I need to add 1 on the right. So x minus 1 squared is equal to 2/3. Now again, square root both sides, and x minus 1 is equal to plus or minus square root of 2/3. And then I add 1 to the other side. And there's my answer. Okay. We got 2 more examples. Again, this is not a perfect square, so to make it 1, I'm going to first get my constant on the right. Now, I have to have that middle term, so that's going to be x minus 5 over 2 squared. So if that is the other piece of my binomial, if I square this, the third part of my trinomial is going to be 25 over 4. And if I add it on the left, I have to add it on the right. So let's combine this. I need a common denominator, so negative 10, that's the same thing as negative 40 over 4. So negative 40 plus 25, that gives me negative 15 over 4. Square root both sides. X minus 5 over 2 is equal to plus or minus. I have a negative inside of my radical, so that's going to be 15 over 4i. There's where our complex numbers are coming back into play. Now I'm going to add this 5 over 2 to the other side. Now I have square root of 4, right? So I can take that out because that's a perfect square. So that's square root of 15 over 2i. And these terms have a common denominator, so the last thing I can do is rewrite this as a single fraction. So 5 plus or minus 15i over 2. Okay. Last one. This is not a perfect square, so let's make it one. Move 27 to the other side. So I want to make this a perfect square trinomial. Half of the middle term is going to be 6. So if this is x plus 6 squared, that third term has to be 36. If I add it on the left, I have to add it on the right. Negative 27 plus 36 is 9. So I square root both sides, and x plus 6 is equal to plus or minus the square root of 9, which is 3. So then I move that 6 over, and I have 6 plus or minus 3. Now, every other time we've done problems like this, we've had not perfect squares. So we've had radicals, and we were leaving it in exact form. Well, these are both whole numbers, so I can actually do this operation. Negative 6 plus 3 is negative 3, and negative 6 minus 3 is negative 9. So x is negative 3 or negative 9. If you end up with two whole numbers, you need to do this operation in the middle. Add the two numbers, then subtract the two numbers. And that is it for our notes today. They were pretty nice and sweet.